Okay, this is from Prevent and Reverse Atrial Fibrillation and Congestive Heart Failure, my book by Pete Rogers. We're on page 36 if you're following along in the book, the chapter on mitochondrial inhibitors and atrial fibrillation. So what this comes out of is I kept in reading through medical literature encountering papers that would discuss mitochondrial inhibition, like Michael Brownlee. The greatest paper ever written on diabetes talked about saturated fat causing inhibition of electron transport on the inner mitochondrial membrane. I'm like, gee, that's interesting. How come I never heard of that in med school? I was like first in my class, fantastic biochemist. I almost considered becoming a biochemist. So I'm like, how come I didn't know that? And then I would come across fluoride being an inner mitochondrial membrane inhibitor. I'm like, gee, how come I didn't know that? And I thought there's got to be more mitochondrial inhibitors. So I started looking them up. Mitochondria is the part of the cell. It's like the powerhouse, the battery, the energy of the cell, the electrical power plant. It's really a nuclear power plant. I'll explain that, but it actually is. It splits the hydrogen atom into its proton centrally and its electron. So it's a magnificent thing. And I started going through the inhibitors, and I'll show you in a moment, though. I own like 7 biochemistry textbooks. All my college biochem books, there's not a word about mitochondrial inhibition. My med school biochem books, nothing. My nutrition biochemistry books, nothing. I'm like, this can't be right. So I started going through the literature, and I went through tons of papers. And I kept finding more and more mitochondrial inhibitors, 10, 20, 30, 40, 50, 60, 70. I've now found over 100 mitochondrial inhibitors, and they're really common things. I'll get to that in a moment, but that's just a warm-up. Typically over like 95%, 95% of your energy is produced in general in your mitochondria. That's a lot. It's about 18 times more efficient. Gets 18 times more ATP produced, adenosine triphosphate, per glucose molecule when you have oxygen present and the mitochondria does the work compared to just running glycolysis in the cytoplasm. Okay. So there's lots of drugs that damage mitochondria. When you damage mitochondria, you run into all kinds of problems. Increased risk of cancer, increased risk of atrial fibrillation, congestive heart failure, all these bad things. Okay, this was a really good paper about the role of mitochondrial dysfunction in atrial fibrillation. This lady, Bianca Brundell, wrote a great paper. And again, I was real impressed by this paper. It was so well written. And, they're a bunch of, foreigners. I don't know where they're from, the Netherlands or something like that. And I'm like, man, was this eloquent and well written. Afib is the most prevalent and progressive cardiac arrhythmia worldwide and is associated with serious complications such as heart failure and stroke. Mitochondria play a central role in cardiac muscle function as they produce energy. In this review, we'll go over the evidence that mitochondria dysfunction is present with AFib. Okay, so that's big stuff because AFib is a bad disease. A lot of people die from AFib. A lot of people become demented from AFib. Here's the paper, by the way, of Michael Brownlee. This is the Sistine Chapel of diabetes papers, one of the greatest medical papers ever written. He's the guy who had type 1 diabetes and was afraid he was going to die in his early 30s, so he tried to figure out the disease, and he did. He won the Banting Award in 2004, and this guy is a bona fide, magnificent genius. Okay, like I said, I read that paper and I started crying. It was so beautiful. It was so perfect. Every single thing you could ask. He goes, well, I answered that question. And then people would ask this question, so we answered that question. His whole life was devoted to this, and it's just a masterpiece. Anyway, what he comes down to is saying saturated fat causes insulin resistance. It's the main thing that does it. Okay. You can also get it. There's other reasons why you can get insulin resistance, but that's the big one. That's the game changer. Okay, a little bit about the anatomy of a mitochondria. There's an outer mitochondrial membrane, OMM. There's an inner mitochondrial membrane, IMM. There's a yellow spot here is the matrix, mitochondrial matrix. And then there's the IMS, that's the intramembranous space between the outer and the inner mitochondrial membranes. Okay. So here is the inner mitochondrial membrane, and you can see what's happening here is the electron carriers are primarily NADH, also FADH2, and when NADH gives its hydrogen to the inner mitochondrial membrane, it's split whereby the proton is pumped into the intermembranous space. H plus is a proton, it's the nucleus of a hydrogen. And then the electron, symbolized here by E minus, is passed from carrier to carrier to carrier. Okay? It's going to go to coenzyme Q, then the complex 3, cytochrome C, and complex 4. All right? And the energy gained by passing it, like a fireman bucket brigade passing that electron down. It's also, you can think of it as like rolling down a hill, and it builds up energy. And it progressively goes to stronger and stronger grabbers of electrons. And the strongest grabber of electrons is oxygen. It's the ultimate electron acceptor. It wants that electron. Okay, and that energy of the electron transport along its gradient is coupled to pumping these protons into the intermembranous space. So you build up a pressurized gradient of hydrogen protons. So it's a charge gradient and it's an electrical gradient as well. And it leads to a net negative charge centrally within the mitochondrial membrane of like 160 to 185 millivolts, which is a incredibly sky-high gradient, the highest gradient in the human body that I'm aware of. Okay, that's big gradient. Okay, it's massive. It's like a lightning bolt inside of a cell. Okay, anyways, then the gradient is harvested at complex 5, which is also called ATP synthase. And a phosphate is added to ADP, adenosine diphosphate, as in having 2 phosphate, gets this 3rd phosphate to become adenosine triphosphate, and now having 3 phosphates. And that is like a $20 bill in the cell. That's what the cell does to do work. That's the main form of cellular energy, okay, for running your enzyme systems and whatnot. Okay, so yeah, the electron, let me just show you the next picture. It'll just make more sense to go by the pictures. Here is, it's written out here to have a negative 160 millivolt gradient. It can be a little higher than that, though. And again, it's like building up pressurized air to build up this gradient, and then you harvest it to make the ATP. If the electron transport chain gets backed up, you'll start dropping electrons, for example, from coenzyme Q, from complex 1. They'll drop into the mitochondrial membrane matrix, and they'll combine with oxygen. And then they'll form what is called a superoxide, which is a free radical, meaning having an unpaired electron in its outer orbital, potentially toxic. Normally, some of this happens all the time, and the mitochondria is good at neutralizing it with superoxide dismutase, SOD. Okay, but still, the point is made. Everything runs based on a proton gradient, and it's a powerful gradient, the strongest gradient in the whole human body, electrical gradient. And it's used to make ATP. That's the important points at this stage in the game. Okay, here's just a picture of the periodic table of elements showing you that oxygen, out of all the molecules in the periodic table of elements, the strongest electronegativity comes from fluoride, from fluorine. And that's hyperreactive free radical intrinsically, okay? And it's a bad actor. Fluoride is bad stuff. It's a poison, okay? But the next most powerful electron grabber is oxygen, which tells you that oxygen is a very powerful molecule, okay? But oxygen, has been able to be harnessed. It's workable. It's a stallion that's been able to train. It's Alexander the Great's Bucephalus. It's a horse that does useful work, whereas fluoride is just a troublemaker. Okay, and again, here's another way of drawing it a little differently. And I'm going to tell you, this is another example of one of the many reasons that close experience with biochemistry and molecular biology makes me believe in God, because it's too incredible that this little series of proteins on the inner mitochondrial membrane in a cell, and a cell can have 1,000 mitochondria, okay, is able to split the atom, do what a nuclear power plant does, splitting the hydrogen into its component nucleus, the proton, and its electron, run those through a gradient, and then create a pressure gradient that is harvested to produce cellular energy, ATP. That's a nuclear power plant. If you got the 100 best biochemists, synthetic chemists in the entire world, and you asked them to make little tiny nuclear power plants that do this, they would tell you to go F yourself. You're insane. How could they possibly do that? You're out of your mind. Well, this was done at the beginning of the world, okay? This is done early on in the beginning of the world, all right? What I'm trying to say is it's miraculous, okay, is how incredible this is. So, and the closer you look at biochemistry, that's what happens. And that's why, like James Tour had said, Scientists aren't getting closer to creating life on Earth. They're getting farther away because the goalpost keeps moving. As you understand it, it's more and more sophisticated. And there's even more. I'm just giving you the simplified version so you can get the main point of it. It's even more subtle and nuanced and complex than what I'm telling you, and more beautiful. So, all right, so that's the point for today, is the inner mitochondrial membrane is a nuclear power plant, splits the hydrogen atom, and uses that to generate a gradient, which is subsequently harvested to produce ATP. So with that foundation, we'll end it for today, and then we'll cover the remaining stuff for the next talk. Hope you found that helpful.